Okay, so today's lesson is on solving problems involving similar shapes. Architects created scaled plans for building houses. Artists use sketches to plan murals for the sides of buildings. Companies create smaller sizes of their products to display in stores. Each of these models is created to show all the information about the real object without being the actual size of the object. Today, you will work with your team to find strategies that you can use when you are missing some of the information about a set of similar shapes. As you work today, look for more than one way to solve the problem. So this first problem says, Keenan loves trains, especially those that run on narrow gauge tracks. The gauge of the track measures how far apart the rails are. He has decided to build a model train of the Rio Grande, a popular narrow gauge train. Use the information to help him know how big his model should be. The real track has a gauge of 3 feet or 36 inches. His model railroad track has a gauge of 3/4 inches. The Rio Grande train he wants to model has driving wheels measured 44 inches. So your task is to find the scale factor and the height of the driving wheels. So for me, the way I thought about this problem is I thought about it proportionally. I know that the real track has a gauge of 36 inches to the 3/4 of an inch, okay, on the model. And I know that the train wheel is 44, so I'm looking for x. To figure out the scale factor, I figure out what did I multiply 36 by to get 44, I'm sorry, the new, what did I multiply 3/4 by to get 36? So I could do 36 divided by 3/4, which is 48, right? Or 148. And then to solve this problem, I'm going to cross multiply. So I'm going to do 3/4 times 44 and 36 times x. So I'm going to get 36x equals 33. Divide both sides by 36. So I get x equals 11/12 inches. So the next problem says, make and enlarge figure 8 right so that it became the similar figure B. His diagrams are shown at right. Write all the ratios that compare the corresponding sides of B to A. So x is compared to 7, so I do x over 7. 5 is compared to 2, so I would do 5 over 2. And 10 goes to 4, so I do 10 over 4. So that says, what's the relationship between these ratios? How do you know? Okay, so they're equivalent ratios. Because they are similar figures. Alright. So find the value of x in this quadrilateral. Does your solution seem reasonable? Are you ready to share your strategies with the class? So I'm going to use the 5 over 2. I can write a proportion. I can say x over 7 is equivalent or equal to 5 over 2. And then I'm going to cross multiply. So I'm going to get 2x equals 35. Divide both sides by 2. And I get x equals 17.5 millimeters. And yes, my answer is reasonable because it's getting bigger. And 17.5 is bigger than 7. Okay. The next one says, Fatima solved for P in the diagram of similar triangles below and got P equals 30. Looking at her answer, she knows she made a mistake. What would make Fatima think her answer is wrong? So in order for this shape to be similar, the shapes are getting bigger. And 50 corresponds to 75 and 45 to P. P has to be bigger than 45 in order for this shape to be similar. I would write a proportion, I'm going to do P over 45 equals 75 over 50. So I'm going to cross multiply and get 50P equals 75 times 45 is 3,375, and then I divide both sides by 50. So P equals 67.5, which is more reasonable because now it's bigger than 45. Alright, so my next problem, I have two shapes that are kind of crisscross each other, but they're similar to each other. So VUM, this triangle right here, is similar to LKM. So because they're similar, and I know that VUM is similar to LKM, VU and LK are similar sides. I also know that these two are similar, and these two are similar. Okay? So when I write my proportion, I'm going to say that 6x minus 3 over 36 equals 42 over 56. Okay? So then I'm going to cross multiply. I'm going to get 56 groups of 6x minus 3 equals 42 times 36, which is 1,512. I get 56 times 6, so I distribute the 56. 56 times 3 is 168. Right, I'm going to add 168 to both sides. $1,680. And then divide both sides by 336. And I get 5. Okay? The last problem is a triangle within a triangle. So it tells me that this should be BCD. The small triangle is right here, and it's similar to the big triangle. So when I do this type of problem, I like to redraw them. So I know that this is 14 and this is 11, and I know that this is 70 and this is 6x minus 5. So now I can write my proportion. These two are similar and these two are similar. So I get 6x minus 5 over 11 equals 70 over 14. Cross multiply. 14 groups of 6x minus 5. 70 times 11, 770. Distribute 14 times 6 is 84x. Minus 14 times 5 is 70. Add 70 to both sides. 84x equals 840. I end up with x equals 10.